We're going to measure the area of this golfing green. Notice it's irregularly shaped. It's not a rectangle. I could draw one big rectangle around it, estimate the area, and say, not bad. I could do it into two separate rectangles and use that to estimate the area. But what we're going to do instead is we are going to measure the length or the width of the green every 10 feet. So I measure that segment and I get 28 feet. I repeat that. Every 10 feet, I measure the length. And these distances are recorded right here in the table. Well, let's go ahead and mark the x-axis. Every 10 feet, I record the area. Now in question A, it says using midpoint rectangles to calculate the area. The reason the caretaker is being lazy in that case is the caretaker can't take as many rectangles. The caretaker can't do a rectangle with a width of 10 feet because there's no reading at 5 feet. There's no distance at the midpoint of that interval. Same thing with between 10 and 20 feet. There's no reading at 15 feet. So I can't use a midpoint estimate. I can use a midpoint estimate, but it won't have as many rectangles. If I choose 0 to 20 feet as being my first interval, I do have the value of the function at the midpoint, so I can take midpoint rectangles with a width of 20. So in our midpoint estimate, the rectangles are going to be 20 wide because I have the value of the function at the midpoint every 10 feet. So my first rectangle is going to be between 0 and 20 feet. And I'm going to use the height of the midpoint rectangle, which I overdrew here. I'm going to use the value of the function at the midpoint to draw the rectangle. So the rectangle is going to be this high for that whole 20-foot span. In the next, between 20 and 40 feet, I'm going to pick the value of the function at 30 feet, at 62. So here's the function at 30 feet. That is going to be the width or the height of the rectangle for that interval. Between 40 and 60 feet, I'm going to pick the value of the function at 50 feet, which is this length right here. And that's going to be the rectangle I use to represent that whole 20-foot interval. And then in this last interval, between 60 feet and 80 feet, I'm going to use the value of the function at the midpoint. So I'm going to take the reading at 30 feet, that's this segment right here, and that segment will be the height for the entire last interval. So I'm going to find the area of these 4 rectangles, and that will be my midpoint approximation. And that's why we use 10 for my midpoint Riemann sum. I'm using 20 as the width of the interval times the height of 28, 62, 55, and 30, those 4 midpoint heights. And here you see the calculation. The width of each of the rectangles is 20. The first rectangle from the midpoint is 28. The second height is 62. The third height is 55. And this last height is 30. So I do height times base, height times base, height times base, height times base, and I get 3,500 square feet. Now my left-hand rectangles, I can use more rectangles. With my left-hand rectangles, I can go ahead and do all 8 rectangles and find the area. So 10 is going to be the width of each rectangle, 0 to 10, 10 to 20, 20 to 30. So 10 is going to be the base. The height is going to be the height on the left for my left-hand rectangle. So my first height is going to be a rectangle with a width of 10 and a height of 0. My next one is going to use a height of 28 and a width of 10. The next one is going to use a height of 50 and a width of 10. The next one is going to use a height of 62 and a width of 10. And here you see that calculation, 3,360 square feet. And then we'll go on. The right-hand estimate is going to give me an estimate of 3,390 square feet. In calculating the right-hand estimate, I don't use a height of 0, because between 0 feet and 10 feet, I'm going to let the rectangle have a height of 28 for that whole 10 feet. Between 10 feet and 20 feet, I'm going to pick the height at the right, and that's going to be the height of that whole rectangle. Between 20 feet and 30 feet, I'm going to find the rectangle that has a width of 10 feet, but a height of 62 feet. And we'll go ahead and go on. In this interval, to estimate the area of the green in this interval, I'm going to pick the height on the right. And we proceed the entire time, the entire width of the green, and add up all those rectangles. Notice that my last rectangle is going to have a height of 3 feet. I don't use 0 feet, the one on the left, but I do use 3 feet, the one on the right, and I get 3,390 square feet for the right hand. If I average my left and right hand rectangles, I will get the midpoint. So since each left-hand estimate and right-hand estimate use the same 10-foot wide interval and uses all the same values, except the left hand uses 0 on the left, the first reading, the right hand uses 3 on the right, the last reading. If I average these two, we get the trapezoid method, and the trapezoids are halfway between the left and right rectangle. So this reading of 3,375 square feet is close to halfway between the left and the right estimate.